Optics. The lecture notes covering the following subjects such as brief history of optics, nature of light, production of light and measurements, and etc. A brief history of optics began at Middle Ages. Al-Kindi, for example, defeated emission hypothesis. Lens was invented by accident in the 12th century AD. Delaporte, Da Vinci, Descartes, Galileo, Kepler formulate geometrical optics, explains lens behavior, construct optical instruments. Beyond the Middle Ages, Newton and Huygens fight over nature of lights. In the 18th-19th centuries, Fresnel Young experimentally observed diffraction, defeat Newton's particle theory, Maxwell formulates electromagnetic equations, Hertz verifies antenna emission principle. In the 20th century, quantum theory explains wave-particles duality, invention of holography, invention of laser, optical applications in communications, fundamental science, medicine, manufacturing, and etc. were invented. Light has the wave-particle duality. Light behaves like waves in its propagation and in the phenomena of interference and diffraction. However, it exhibits particle-like behavior when exchanging energy with matter, as in the Compton and photoelectric effects. Electrons have similar properties. Bohr's principle of complementarity. Photons and electrons were neither waves nor particles, but something more complex than either. An electron is capable of both absorbing and emitting a photon. The wave description of light will be adequate to describe most of the optical phenomena treated in the course. Quantum mechanics describes both light and matter together with special relativity as follows. A crucial difference between particles like electrons and neutrons and particles like photons that the latter have zero raised mass. For example, this is an example of how to find optics and given by the given formula. Electromagnetic spectrum. User relations. Here the visible light is shown in an enlarged band. Electromagnetic spectrum arranged by wavelength in meters and frequency in hertz. The narrow portion occupied by the visible spectrum is highlighted. Radiometry. Radiometry is a science of measurement of electromagnetic radiation in optics. Here are the definitions of energy density, energy power, excitant, irradiance, radiant intensity, and with the solid angle irradiance. And the radiometric terms are radiometric energy density, radiant flux, radiant power, radiant excitance, irradiance, radiant intensity, and radiance. And the given abbreviations can be used in the formula and in your in the solution in the solving problems. The radiant intensity from the sphere radiating watts of power uniformly in all directions is this by formula. The inverse square law of radiation from a point source is by this formula. The figure 2 and 3 shows the illustration of the inverse square law. The flux leaving a point source within any solid angle is distributed over increasingly larger areas, producing an irradiance that decreases inversely with the square of the distance. Figure 2.4 is a radiant flux collected along a direction making an angle with the normal to the radiant surface. The projected area of the surface is shown shaded. Radiance. The radiance intensity per unit of projected are by given formula, and they are specified direction with this. We can consider the radiant surface as a collection of infinitely many point sources. As it's shown before, moves can be changed by Lambert's law. Diffusive surface by Lambertian surface, a surface whose radiance is independent of the view angle. As shown in figure 1.5, the radiance has the same value at any point along a ray propagating in a uniform non-absorbing medium. Here is an example for solving optics, and by determining the solid angle and the radiance of the laser and the given solution.